Well, I've taken the liberty to advance the date to March 18th. Let's turn on TransX, both sides. And what we're going to do is first target Mars. And we'll go forward. Notice we actually have the scenario set up with a close encounter there with Mars. We'll escape and forward, and then choose Earth. And what we're going to do is sling off Mars, but there's no way the gravity is going to be enough. So we're going to actually fly inverted in the atmosphere. And let's bring, that means that we're actually doing a sling, but we're not going to inherit velocity. So we'll change inherit velocity to no. Then we'll have to add some velocity. We have no idea how much, so let's just say about that much. And we'll bring our outward angle. Now it's pretty tight here. Let's just see if there's enough velocity to bring it into Earth. Well, we can see that it's making it at Earth, but it's the resolution's not good. So we'll zoom in by going to Setup, and there we go. One more, Scale to View, to Target. Now that's Earth in the large blue, and you can see the sling is bringing us in tight. And we're a little bit behind it. Let's go ahead, pardon me, there, and play with the outward angle. And you can see we do have a chance of making it there, but we're going to have to come inside the Earth's orbit to gain on it a little better than we did. So we're going to have to increase the velocity. Let's try increasing it to about there, and then come back and see what happens. It's still got, the closest is somewhere in about here. And let's also change our inclination just to bring it somewhere around there. And we'll go back to velocity. There it is. Increase our velocity again. And we can see that our lines are coming tighter. And that's it. And we'll play with, now we're going to keep an eye on our close approach. That's way too much. We'll come back. That's good. Now we'll play with the inclination and pull inclination across on top. It's pretty much there. Outward again. That's wrong direction. And forward, we can see there's Earth. Now coming back all the way. So what we have is, this is our slingshot view of Mars. And we're going to take a look as we come in close. We're going to set up a maneuver. So again, like the other one, it's the resolution's poor. So we'll go scale to view. Here we go. There's Mars. And we are chasing, we're gaining on Mars right now. So we're going to set up a maneuver to try and get the inclination 0. One other thing that's interesting is that we want to have the PE ratio. Now normally you would have this set to 1, but it's not going to work that way for an aero sling. If we go forward here, we can see that we have the periapsis to the planet ratio is 0.001926, which is just the tiniest fraction. That means we're going to, if we were going to do it by gravity, you'd have to compress Mars down to the size of a black hole and zip around it really tight within a couple kilometers of the center of Mars. If we take the inverse of that, I'm going to pull up a calculator here and just say 1 divided by 0.001926, we get the number 519. So if we come back, this number here, we're going to shoot for around 519, 520, somewhere in that range. So maneuver on, and let's try see what happens here with outward. Outward takes it in and out, and we're looking at where the green line goes relative to the center. So it goes in and out away from the planet. And let's see what change plane does. Okay, so that swings aside. So we've got a couple axes in and out. Now we want to see where we're going with the inclination. It's getting less by going on the plus here and taking it this way. So we're going to rotate the green line another 58 degrees by going up, and then we'll come back to outward and bring that across, and you can see what's happening here is we're going to reduce that down, and that's almost 0. Remember, this number we want it to be around 519 or 20. So let's go back to change plane. That's 579. There it is, and we want to get inclination back down again. And reducing that. That's good, and we'll go up here one more. Wrong direction. Around there. So that's pretty good. Now what we'll do is burn this maneuver, and it says we only have 2 meters per second to do. So we'll just not even rotate, we'll just translate. I'm going to translating downward to bring the X up, and then translating left to send it to the right, and then we'll do a little forward and reverse to bring the value to 0. Pretty close. We'll turn our maneuver off. And now what we want to do is advance the time to the periapsis. And there we go with advancing. When we get in tight, we're going to want to check to make sure we are missing the atmosphere, but with, or I should say hitting the atmosphere, but not so low that it actually hits the planet. It's coming down. I'm going to slow it here, warping down a bit, starting about now. What I'm also going to do is I'm looking at the orbit sun, and when I see it change to being Mars-centered, there it is. Now I'm going to turn prograde, and that's pretty good. And now I want to see how close I am. One way is with orbit, automatic reference, Mars. It says we're 31 kilometers below the surface. So we're going to go translating to the right, and we're going to raise that up to around 35. That's a good altitude to be diving into the atmosphere. And also, on the right side, our inclination by going up or down. Let's go up. There we go. We could warp ahead a little bit now. And on the left side, let's get a different view. Projection, there we go. You can see us arriving. What I'm going to do now is rotate around inverted. That's pretty good. Also, if we notice here, we do have our retro doors. We can go ahead and close those off. And we're set now to enter the atmosphere, which is a conclusion of part 1 of the solution to this problem.